Your morning routine, that's an algorithm. Your grandma's special recipe, that's an algorithm too. Even the thing that picks the next song on your Spotify playlist, yep, you guessed it, it's an algorithm. But what does that word actually mean? Okay, let's dive right in because I promise we're going to make this super, super simple.
And that's really the whole secret. The word might sound a little technical, maybe even a bit intimidating, right? But the idea behind it is something you're already familiar with, something you use every single day. So let's pull back the curtain.
Just think about it for a second. You wake up, you brush your teeth, you get dressed, you grab some breakfast. It's a clear sequence of steps you follow to get a task done. That's it. That's your own personal algorithm for starting the day.
Or what about a recipe for your favorite dish? You've got a list of ingredients and a very precise set of instructions to turn those ingredients into a meal. That's a perfect classic example of an algorithm.
And now let's connect that to the digital world. The logic that recommends the next YouTube video for you, or the next post on your Instagram feed. It uses that exact same principle of step-by-step instructions. The only difference is, it's working at a completely mind-boggling speed.
All right, Section 1, the universal blueprint. So all of these things, from making breakfast in your kitchen to the apps running on your phone, they're all built on the very same fundamental idea. Let's define exactly what that is.
And there you have it. That's it. No complicated jargon, no hidden mystery. An algorithm is simply a recipe. It's a set of clear, step-by-step instructions to get you from a starting point to an end point. This definition is the foundation for everything we're about to cover.
Now, what's really cool is that basically every algorithm follows this universal blueprint. It always has these three parts. First, you have the input. These are your raw materials, like the bread and fillings for a sandwich. Then, you have the process. These are the actual steps, the recipe you follow. And finally, you get the output, the completed task, your finished sandwich. Just remember that flow: input, process, output.
Okay, moving on to Section 2, the rules of the game. So for that universal blueprint to work flawlessly every time, especially when a computer is involved, that process part has to play by some very important rules. Let's see what they are.
So 3 key things here. First, an algorithm has to be precise. You can't just tell a computer to add some salt. What does some mean? It's too vague. You have to say, add 1 teaspoon of salt. Super clear. Second, it has to be finite. This just means it needs to have an end. An endless loop of instructions is basically a broken algorithm. And finally, the really great algorithms are efficient. They solve the problem in the smartest, fastest way possible, without any wasted steps.
All right, Section 3, algorithms in action. Let's see how this blueprint and these rules come together in both the real world and the digital world. We'll start with something old school, the library, or, well, a dictionary.
So I want you to actually think about this. If I gave you a massive 1,000-page dictionary and asked you to find the word zebra, what would you do? You wouldn't start at page 1 with the letter A and just read every single word, would you? Of course not. Your brain knows a better way. You instinctively open the book somewhere near the middle. You might land on the letter M, and you instantly know zebra comes later. So you completely ignore the entire first half of the book. Then you just repeat that process, splitting the problem in half over and over again. This incredibly smart and efficient method is a famous algorithm that computer scientists call a binary search. And get this is the amazing part. Using that binary search algorithm, you can find any word in that huge 1,000-page dictionary in about 10 steps. Just 10. Not thousands and thousands of steps, but 10. That is a truly great algorithm at work.
Okay, so from an old-school dictionary, let's jump to something you probably use a dozen times a day. A Google search feels like magic, right? But really, it's just an unbelievably complex and fast algorithm following the same basic logic we've been talking about.
And look at this. It's the exact same blueprint as making a sandwich. The input is your search query, like best pizza near me. The process is a blur of billions of lightning-fast steps. It breaks down your query, checks your location, searches countless web pages, and ranks them all by relevance. And the output? That perfectly organized, ranked list of pizza places you get back in less than a second. Same structure, just on an absolutely incredible scale.
And that brings us to Section 4, your 3 key takeaways. We've gone from the kitchen to a dictionary and all the way to a global search engine. So let's lock in the most important ideas to remember from all this.
Okay, so if you remember nothing else, remember these 3 things. 1, an algorithm is just a recipe, a set of clear instructions. That's all. 2, every single algorithm is built on that same predictable blueprint.
input, process, output. And 3, these simple recipes are the invisible engine powering pretty much our entire digital world, from your Netflix queue to your GPS.
And this right here, this is why algorithms are the absolute bedrock of all modern technology. Their real power comes from their predictability. If you give the same algorithm the exact same input, you will get the exact same output every single time. That rock-solid reliability is what makes our digital world possible.
So, now that you've got the foundation, let me leave you with a final thought to chew on. We've talked about algorithms as fixed recipes written by people. But what happens when we build algorithms that can learn from data and start to improve or even write their own steps without any help from us? Well, that's the world of machine learning and AI, and that is where things get really interesting.